All right, so we are actually staying in the same section. So this is going to be 2.4 continued. And today we're going to get into the rational root theorem. We're going to get into multiplying. We're going to get into finding left and right bounds. And if we have time, we might decide to factor a polynomial completely. We'll just see. Might save that for tomorrow. Okay? Okay. So I actually want to jump right in with an example. I'm going to start right off with an example because this is review, this first part. So I think it's just going to be easier if we start with that. Let's say, so we're starting with number 27 through 29. It's going to look like this. It's going to ask you to find the polynomial with leading coefficient two and has degree 4 and zeros at -3, -1, 0, and 5/2. So obviously if we have 4 zeros, that means it's got to be x to the 4th power. Makes sense for the degree. In order to get a coefficient of 2 on the front, what he says we're going to do to our polynomial when we're all done? Times it all by 2, exactly. All right, it's just a multiple of it. So really we've got to take our factors at the bottom and create our polynomial. So we're going to start with this one. If I have a 0 at -3, I have a factor of x plus 3. If I have a 0 at -1, I have a factor of x plus 1. If I have a 0 at 0, I just have x. And I'm going to write that in front. This is the tricky one. If I have 5/2 equals my x. So, yep. Yeah, so we'd have 5 equals 2x. And then we would move it over to get our 0. We get 2x minus 5 as our other factor. Way to remember that. Good job. All right, now we're just going to multiply it all together. So I'm going to start by multiplying my last two first because those are the two tougher ones. So I'm going to do a little box. I'm going to put 2x minus 5 on the top. X plus 1 down the side. X times 2x is 2x squared. X times -5 is -5x. 2x times 1 is 2x, and -5 times 1 is -5. So we have 2x squared minus 3x minus 5. What do you want to multiply that by next? Okay, so we can do it one of two ways. You can distribute the x through and multiply by x squared plus 3x. Or you can multiply by x plus 3 and then distribute the x through the whole thing. All right, x squared plus 3x is what we're going to do. X squared plus 3x. You can do it either way. They both will get the exact same answer. So here is our last box. We're going to put the longer one across the top. Does it matter? No, it's just I like it going the long way better, so that's the way I always do it. All right, so 2x squared times x squared is 2x to the 4th. X squared times -3x is -3x to the 3rd. And -5 times x squared is -5x squared. You guys check my math. It's been a long day. 2x squared times 3x would be 6x to the 3rd. -3x times 3x is -9x squared. And -5 times 3x is -15x. All right, so we end up with 2x to the 4th plus 3x to the 3rd minus 14, that's supposed to be squared there, lost that, minus 14x squared minus 15x. Does it have degree 4? Does it have a leading coefficient of 2? Then we're done. Technically, it should be f of x equals, but I'm not super picky about that. So do we have a question on this at all? So then let's just take it a little bit further, because of course that's what we got to do, right? All right. So here's example number 2. In example number 2, this is going to cover your number 31 for today. Using only algebra, find the polynomial for, here's a table you're going to be given this time. Usually we would plug that into our calculator, but we're going to do it longhand using only algebra. So we have x and we have f of x. So let's go with -2, 0, -124, 1, 0, that's a 24, come on now, 1, 0, and 5, 0. So let's really look at what this table means, okay? This table is giving us how many zeros? 3 zeros, right? Because there's this one and those two. This one is going to be used to find our leading coefficient, right? Okay, so technically what we have up here to start with is we have f of x equals, we don't know what our leading coefficient is, so I'm going to put an a, just like we always use. We use a for our leading coefficient. I have a 0 at -2, so what factor is that? X plus 2, good. I have another 0 at 1, so that factor is x minus 1. And I have another 0 at 5, so x minus 5. Yeah, so this is actually a point. So we're going to actually, this is a point, -124, that we get to plug in to find a. Okay? So we are going to go straight to, let's see if we can't figure out what our a value is. So remember that this -1 is our x value and 24 is our y value. So we have 24 equals a times -1 plus 2 times -1 minus 1 times -1 minus 5. -1 plus 2 is 1. -1 times -1 minus 1 is -2. And -1 minus 5 is -6. Can I multiply those all together? So I have 24 equals 12a. So what's my a value going to be? 2. A equals 2. So then you're going to go back up to our a and plug in 2. And I'm going to be okay if you leave it like this today. Leave it in factored form. I don't know. We'll see where tomorrow brings us. Funny. All right. Okay. Any question on just doing this? Yep. Right. We're not going to multiply it out and get a big polynomial today. The idea is to use your zeros to write factors. Use those factors to find a. All right? Okay. Moving on then. I want to talk about the rational root theorem. Does anybody remember the rational root theorem? Yes, okay. So this is where we find all possible zeros. Then from your all possible zeros, then you find actual zeros. From that list, right? And we actually use those in order to start dividing to find the other stuff. You guys recall that? All right. And does anybody remember how many actual zeros you had to find? You're close. 2 less, exactly, because we needed to get it down to a quadratic. So, 2 less than highest degree. So we always said that if the highest degree is 5, we take off 2, which means we've got to find 3 zeros. Right? Because we need to get it down to a quadratic. All right, so to remind you how this goes, you take all factors of the last number and divide by all factors of the first number. So here is example number 3. I know you guys have done this many, many times. You may have wanted to forget it, but you know. All right, so this is going to do the 33 through 35. And your directions are going to ask you to write a list of possible zeros, then find all actual. All right. So today we're not finding all of the zeros. We're just finding the actual from the list we're making. Okay, you guys understand the difference? So out of the possible ones, we're just figuring which ones are zeros out of our possibles. All right. So let's say we have something as wonderful as f of x equals 3x to the third minus 7x squared plus 6x minus 14. All right, so first we're going to start with all the factors of 14, which are 1, 2, 7, and 14. I agree. And we're going to divide that all by, what are the factors of 3? 1 and 3. Okay, so here is our potential possible list. Start with 1, and we're going to go 1 over 1. And remember, it's plus and minus 1 over 1. Then plus and minus 1/3. So we've done with 1. Now we're going to move to 2. Plus and minus 2 over 1. Plus and minus 2 over 3. And we're going to move to our 7. Plus and minus 7 over 1. Plus and minus 7 over 3. And we're all the way to 14. So we have plus and minus 14 and plus and minus 14 over 3. So we have 16 possible. Now out of those 16 possible, I need you to find the zeros. How would we do that? Plug them all in is what we're supposed to do, right? Now, I was nice and said, you know what, you can grab your graphing calculator and see if maybe that gives you a hint of which one works, right? So, I put now, plug them in. All right, so go ahead and graph, first of all, 3x to the third minus 7x squared plus 6x minus 14. And I don't have that. Rachel said she got a positive 7 over 3. Anybody else? Okay. So your graph comes up like this, where it actually only crosses one time, right? So what does that tell you about your other two zeros? They're going to be what? Very good. They're going to be imaginary, right? So yes, you just have to go to here, do your left bound, right bound, and find your zero. Okay? I'm okay with you doing it that way. Questions? No? Again, this is review, right? Okay, so you have to use your calculator. You're going to go second, trace, down to your zero, which is, I think, 2, right? Hit enter. It says left bound. So you move your cursor so it's like right below this, so it's to the left of where it is. And you get a little line. Then you got to do right bound, so then you move your cursor above it. And then it says guess, and you hit enter one more time. .3 repeating? Yep. Okay? All right, so here's the one thing I want to talk about that's new today. And if you give me a good solid 5 more minutes, I'm going to shorten that assignment up, okay? Right? Give me a good solid 5 minutes. We'll make that a lot shorter. All right, so here's what I really want to talk about. Something new is we've never looked for our bounds. Look, we never looked for a lower bound or an upper bound. So when we talk about bounds, we're looking for numbers that will help us narrow down where our zeros are. So when you are doing bounds, you can divide by any number to your polynomial. You're going to get a remainder, right, if it's not an actual zero. But if all numbers are positive, then it's an upper bound. If, when you do synthetic division, all numbers alternate signs, then it's a lower bound. So for example, if I had something like, I need a good example, hold on. Let's say I have 2x to the 4th minus 7x to the 3rd minus 8x squared plus 14x plus 8. And I want to know if all the zeros fall between, let's say, -2 and 5. Maybe. Come on, catch up. All right? So I just need to know if all my zeros are going to fall between those. So I'm going to do synthetic division. And I'm going to start with, let's start with 5. I'm going to put that at the top, maybe. Okay? So I'm going to put my 5 on the outside. At the top, I'm going to put 2, -7, -8, 14, and 8. If I bring down my 2, I get 5 times 2 is 10. Add them together, I get 3. 5 times 3 is 15. Add them together, I get 7. 5 times 7 is 35. Add them together, I get 49. And 5 times 49 is 245. Thank you. I get 253. So all of these are all positive numbers, which means 5 is an upper bound. There are no zeros outside of that. Okay? No zeros to the right of that 5. Let's do it again with our -2. So I have 2, -7, -8, 14, and 8 again. And this time I'm going to use -2. I bring down my 2. -2 times 2 is -4. Add those together, I get -11. -2 times -11 is positive 22. Add those together, I get positive 14. -2 times 14 is -28. Add those together, I get 14. Negative 2 times negative 14 is positive 28. Add those together, I get 36. So what do you notice about the signs in this one? They alternate, which means that negative 2 is a lower bound. Nothing will fall outside of that. Okay? So, in problems 37 through 43, they just want to know if they're upper or lower bounds. They give you the K value to put on the outside. They tell you what to divide synthetically. You just look at it. If they're all positive, you say upper. If they alternate, you say lower. If it doesn't do either, you say no. Okay? So, let's change that from 55 to 43. All right?